We are FREY Engineering, and we are excited to showcase our work on the Oak Street Stormwater Infrastructure Project. This project is part of the Downtown Stormwater Improvement Plan and will help contribute to resolving the urban flooding issues in downtown Fort Collins. FREY Engineering has partnered with the City of Fort Collins to design an enhanced streetscape that will include local stormwater quality systems in the form of a low-impact development, also known as an LID.
The current state of the Oak Street drainage system is both outdated and inefficient. Urbanization has contributed to an increased frequency, flow rate, and duration of stormwater discharges. When combined with a lack of stormwater infrastructure, the effects of a high-intensity storm can lead to hazardous situations. Incorporating an LID system on Oak Street will minimize the negative effects of urbanization and allow for more stormwater infiltration and storage. Our LID design on Oak Street aims to improve the quality of runoff and reduce peak flows following a heavy precipitation event.
Along Oak Street, there were 3 intersections that FREY Engineering considered for the installation of an LID. The 3 locations were House Street, Meldrum Street, and Washington Avenue. Each location was compared to each other based on pollutant removal effectiveness, cost, traffic safety, aesthetic, and ease of maintenance. After a multi-criteria decision analysis, the most well-rounded location for an LID design was Oak and Washington.
Using EPA's SWIM software, we simulated a 2-year storm to gather hydrologic data and its effects on Oak and Washington. Our findings indicated that in an 8-hour period of a 2-year storm, the max depth of water would reach around 1 foot within the first hour, and the total inflow of stormwater would reach its max at approximately 60 cubic feet per second. The LID design we chose for Oak and Washington will be a sand filter. This design consists of a surcharge zone underlain by a sand bed and underdrain system, which will allow for a greater depth of storage and will be effective at removing nutrients given a smaller available surface area. This design will also require less maintenance due to the limited vegetation.
With the designed water quality capture volume of 4,977 cubic feet, our LID system will remove approximately 85% of total suspended solids, 50% of total phosphorus, and 35% of total nitrogen from stormwater runoff entering the Poudre River. Our design will contribute to an improvement in water quality and mitigate the severity of flooding event along Oak Street.
This project will provide long-term protection for the community of Fort Collins. It is not a matter of if these large storm events occur, but rather a matter of when. Our LID system will contribute to the overall improvement of stormwater infrastructure in downtown Fort Collins. FREY Engineering would like to give a special thanks to Heather McDowell with the City of Fort Collins, Dr. Chris Thornton with the CSU Department of Civil and Environmental Engineering, and Brick Zivkovich with the Mile High Flood District.